So this view what we have, that is the planform view. Okay, the top view of an complete wing, that is the planform view, and the area what we have with respect to this complete wing, that is the planform area. Okay, and these are things we have covered. See, here we have different types of aircraft. Okay, these all different aircraft that we have. Okay, so the platform view, the top view of a different aircraft wing, also we have different type of wing with respect to the different aircraft, right? So the platform view is different, and based on that, we know the platform area also will vary, right? And based on even that, our overall aircraft performance also will get change. Okay, and similarly we have different type of wings. Okay, and this all uh, figure what I have shown here. Okay, the platform view of a different wing. Okay, in here section what we have, the wing section and the view. So we have to discuss about that today. Okay, with respect to our open VSP. Like this kind of view, what we can able to see in a 2D form, the same kind of view can be done by using our open VSP, which means you can design the model, this kind of model. Okay, like rectangular based. Okay, so what I'll do, just I'll open the open VSP. Okay, default I'll select any one wing and I'll add. Okay, so for this wing, what we can do, we can change this default wing into this shape, the platform view what we have for this three wing, different taper ratio we have. Okay, in this case the taper ratio is same because it's completely rectangular based wing. Okay, so to do that, what we have to do, we have to maintain the equal length from root to tip, right? And if we use the symmetry option, then we'll get other part also. So that can be done. Just what we have to do, we have to go to the section and the plan. Okay, so here we can keep same root chord and the tip chord, and you can change your sweep from 30 to 0, because in this case, see, here we don't have any sweep angle. Okay, wing is completely rectangular based wing, there's no any sweep angle. So that's why what we have to do, just we have to type 0 and we have to enter. See, so whatever we got, this is our rectangular based wing. Okay, so this one we can able to see in this form, like this. Just use your top view, and this is your rectangular based wing, which means this is the platform view of an rectangular based wing. Okay, this one. And for this we can even keep in ISO, or you can shade. Now for this again we can change its platform view from this shape to this shape. Okay. The second one, the taper ratio is completely varied from root to tip. That can be done. So what we have to do the changes, just we have to click on wing and just we have to vary the root chord and tip chord. Okay. So I'll maintain this root chord 5 meter and tip chord 1 meter and I will enter. Okay. So similarly on this side we have to do yes. Yes. So like this you can convert your planform views, which means as per your requirement you can change your planform view. Okay, from rectangular based to the very taper based wing or triangular based wing or triangular based planform view. Yes, so this one is like this is what we have. And third one, this delta based. Easily we can do changes. What we have to do, just we have to vary the sweep, which means we have to maintain the sweep angle from some angle to zero. Yes, like this. Okay, right. So here, by using our open VSP, we can do changes as per our requirement, which means the planform view, right? The top view of our incomplete aircraft wing. Okay, what we have this aircraft wing. Okay, any aircraft wing. Okay, suppose mm, you want to change complete wing from rectangular base to the swept wing or tapered wing. So like that, changes can be done, and after doing the changes, just you save and you can assemble to your aircraft model which you have to do alterations and all. Okay, and like this we have different variations. Okay, and this okay, here we have two sweep. One is near the inboard and one more the outboard sweep angle. Okay, so that also can be done. So what we have to do that we have to use the sections. Okay, here we have currently only one section. So just split that section into two. Okay, so we have split our complete wing section into two sections. The first section is from here to here, and the second section is from here to here. Okay, see. Okay, so this is our second section, and this one is our first section. This one. Oh, I will convert this into wireframe so that yeah, see. So this one is our complete first section, and this one is our second section. So what I will do now, I'll yes, I will do similarly like this, which means top view of a wing with two sweep angles, right? So like that only we'll do now. Yeah. Okay, so here we have one section. I'll come to first section. So this is the first section. So same angle we have, and similarly we'll change our second section angle. Okay, so first section angle, sweep angle, how much we have? Uh, just input that as 30. Okay, okay, wait. Yeah. So this is first section angle is changing. Now I'll jump to second section. Like this alteration you can do. Right, we have two sections, right? Inboard and outboard. Similarly, here we have inboard and outboard. Okay. By writing this, we can delete this, and again we can take one more wing, and we can add, and we can do changes again. So this one I'll maintain 0, okay, and I'll split my section. Okay, I'll jump to second section, and just vary the sweep like this. Okay, like this you can change inboard side or outboard side as per your requirement. You can maintain your angle 20, 30, 40, or minus 20, minus 30, like this. And yeah, after this you can share this. Okay, like this we have different wing platforms. Okay, so yeah, this is completely rectangular wing with the same platform area but different aspect ratio. So what I will do, just I will add one more wing. I'll delete this. Okay, I'll add. I'll convert this into rectangular based wing. I'll maintain same root chord and dip chord, and sweep angle 0. Okay, so the aspect ratio of this wing is 9. Okay, now what I will do, I'll add one more wing. I'll share this. I'll add one more wing. Okay, so this is the second wing. I'll change its location. Okay, yeah. So for this wing, I'll do some changes just to show the aspect ratio. Okay, different aspect ratio. So previously I have given a root chord 2 2. So now I'll decrease the aspect ratio. Okay, which means instead of 2, I'll just type 1 meter and 1 meter. That's enough. Okay. And similarly sweep I'll maintain 0, because I'm showing example of this rectangular wing with same platform area but different aspect ratio, right? So here we have two wing. Okay, here we have two wing. First wing, yeah, this one. I will call this one as our first wing. Okay, yes, aspect ratio is 9, and I'll jump to the second wing. Aspect ratio is 18, right? Here The span of the second wing is 18 meter. Okay, and the span of the second this wing is 18, but chord length is changed. Okay, so because of that, area also got changed, the parameter. Okay, similarly in this case, the chord length is only 1 meter. Okay, so that's why overall area is just 18 meter square. So aspect ratio, that is 18, in this case 9. So I'll, yeah, for this case again you can decrease the span. Okay, and you can able to see, because of the decreasing in the span, your aspect ratio and area is varying, right? So here we have first wing aspect ratio 9 and the second wing aspect ratio is 11. Okay, which means the parameter what we have, the span and the area and the chord, those parameter will affect to your aspect ratio, because we know the aspect ratio, that is uh, yeah, that. Okay, AR is equals to B square by S, right? Which means aspect ratio is directly proportional to your square of span length. Okay, so suppose this is your wing. Okay, and as I discussed in the previous class, this is our span B. Generally, we will call this as B, and this is the complete area, wing area. Yes. Okay. So if I decrease the wing area, yes, then overall aspect ratio will increase. Okay. So that variations we can see here. Okay. So okay, okay. So here what I'll do, I'll disturb to the span. Okay, span is directly proportional to your aspect ratio. Okay, so if I increase the span, then we can able to see the number aspect ratio is increasing. Okay, if I decrease the span, then the area is decreasing. Okay, and your aspect ratio also decreasing. Right. So this planform views and section, wind section, these all things are very important to know, because if once we know how to play with these parameters, okay, then we can easily design any kind of wing model as per our requirement. Okay, like high wing, low wing, okay, high aspect ratio wing or low aspect ratio wing. Like this we have different wing sections which I have already discussed. Okay, like this. Okay, compound based, trapezoid, triangle. Okay, low wing, mid wing, shoulder, high wing. Okay, so here these are what I have shown. Okay, so these wings, what we have, that is low wing, which means wing has been placed below the fuselage. Here wing is placed exactly at the mid section of the fuselage. So like that changes you can do in the open VSP. Okay, suppose you have added the fuselage. Okay, so for this fuselage, now see the wing is exactly at the middle side of this fuselage, right? So that changes can be done Just what you have to do, you just click on the wing, okay, and vary your location, okay, along x, along y, along z. So like these changes you can do, and you can place your wing, okay, like this. High wing, and this one also I will change. Just click on that wing and change your wing location from midsection to the other location where you want to place. Now I'm roughly doing, okay. You can uh, use your parameter values. Yeah. So I'll take this wing little bit back side. To do that, what I have to do, I have to use my x opposite to that. Yeah. So and I'll click on the fuselage. I will share this. We can able to see. Okay, one wing we have above the fuselage and one wing below the fuselage. Okay, which means this category. Okay, high wing and low wing. Here we have both types. Okay, high wing and the low wing. If you want to add at the middle side, okay, then just click use the wing and add. Okay, change its parameter. I mean, like convert that into rectangular or as per your requirement. Now, what I will do, just I will use the default wing. I will not do any changes. Okay, I'll just change the location. Yeah, so like these alterations you can do as per your requirement. This is just a rough model, just to show this all thing can be done like this. Okay, we have other sections like this. Okay. Box wing, annular box wing, cylindrical wing, joint wing, okay, flat angular wing, rhomboidal wing, okay, wing support, constant chord, tapered, trapezoidal, okay, compound, tapered, and what we have different wing sections, okay, the planform view, what we can able to see, okay, so like this. We have different platform views, no, big platform view, so that can be done easily in the open VSP. Or if you want to keep this kind of shape like elliptical or semi-elliptical, that also can be done. And delta is like a tailed delta or tailless delta wing or crop delta, okay, compound delta, oblique delta, or ogival delta. So that type of wing easily you can design. I'll delete these all things which is not required now. Yeah. I'll add, so see, for this you can do changes as per your requirement. Now I will show this one. Complete data based along with this flat fuselage. Okay, and I'll change this wing shape in delta form. I converted this. Yeah, I convert. this swept wing into a delta wing. So just have to play with these parameters. Okay. Sweep angle element in 0. Okay. And I'll just increase the span and little bit chord, and I'll move this wing along X, and finally I will shade, and I will show the top view like this. Okay. Here this one is like a crop based. I mean this kind of wing I have done. Like this as per your requirement. If you don't want crop, just come to this tip section and keep your tip section. Yeah, but I'll just show it. I'll just come to tip section and I'll maintain this tip length 0, tip chord length 0. Okay, yeah, right. Which means here, whatever I have shown the rough sketch, okay. So just finally, I'll tell the thing what I want to convey by this models, whatever I have done, rough models, okay. Here, whatever we have seen the views, different platform views, okay, wing platform view, okay. So that type of platform wing, okay, or that type of sections you can easily design in the open VSP. That is what the today's topic, okay. That is the wing section and the platform, okay. So in future we'll be going with different wing, okay, like this. We have different wing section, okay. Cranked arrow, M wing, W wing, okay. And we have other different type of scenario: conventional tail, canard, tandem, three surface, okay, outboard, tailless, okay. And even you can able to see the handle and handle base. This one I will show die handle and handle. I'll just delete this fuselage, okay. I'll delete this wing also and add one more new wing. So now currently this wing, yeah, here we don't have any unhandle or diagonal based angle, okay. As we know, if your wing, okay, suppose this is a fuselage, okay. For this fuselage, if you are designing wing with some angle, I will call this is the axis, okay. So if you are placing the wing exactly at the middle, okay, and simultaneously you are giving with the I mean like you are placing your wing with some angle like this. So that time we can able to tell that the wing is a diagonal based wing, okay, which means the angle what we have, this angle is known as the dihedral angle, okay. Wing is assembled with this fuselage with some inclined angle. That inclined angle with respect to this axis, what will get the theta, okay, that is known as the dihedral angle, okay. And if you are going opposite to this, which means if you are placing your wing opposite to this like this, what we have, that is the unhedral angle. Okay, so this is our overall span B. I'll do in this open VSP so that you'll understand. Okay, so you see here dihedral angle is 0, which means the wing is completely rectangular based like this, which means with respect to the fuselage, wing has been assembled in this form without any angle. There is no any angle here, right? There is no any unhedral or dihedral angle. Okay, which means wing has been not placed in an inclined form. Okay, it has been placed with respect to the axis like this, the axis what I have shown, right? So if we are placing with some inclined angle, then we are calling the angle what we have, the inclined angle. Okay, that is the dihedral, and opposite to that the unhedral angle. Okay, so here what I will do, I will change the angle, dihedral angle. Okay, here currently we have 0, 0 in the sense in this form like this. Wing has been placed with respect to the fuselage, or a wing is assembled to the fuselage directly in this form. Okay, so the view what we have like this. Now what I will do, I'll add fuselage also so that it will be clear to you. I'll add fuselage. Yeah. Okay. See, the wing is placed and assembled. Okay, without any angle or diagonal angle. Okay, so now I'll change the angle from 0 to plus 30. Plus 30 in the sense the wing will get inclined to positive 30 degree like this. Okay, it's too much, right? So I will just type 20. Yeah. So yeah, see here. Here we can able to see that wing has been inclined with respect to the fuselage axis. Okay, with some angle. The angle what we have typed, that is 20 degree, which means positive 20. That indicates the angle. Okay, that is the dihedral angle. Okay, and if I tap opposite to this, which means minus 20, then that will be opposite. Okay, so that time we are calling the angle negative angle. Okay, wing is inclined towards the negative angle, that is minus 20 degree. Okay, so in that case we are calling the angle between this to this what we have, that is the unhedral angle. I mean like this. Okay, this angle, that is unhedral, and if you incline your wing like this, then that is dihedral angle. Okay, so I have figure I will show. Yeah, dihedral and unhedral. So like this, you can do changes, and similarly, we even have high lift devices. Okay, that high lift devices we can add our uh, yeah, that's yeah, for our wing we need those high lift devices now. So I'll just delete this fuselage. I'll select wing. Even I will delete this, and I'll just add one more new wing. Okay, so I'll shade this wing. just to show this. Okay, so here we can come to subsection and we can add. Okay, like this you can add your slot, slat, cut, leading edge flaps, and other handle devices. Okay, so by doing this kind of changes, you can see your overall plan from view. Okay, so this is all about today's topic. That is the wing sections and plan forms. Thank you to all. We'll continue tomorrow.
Thank you, sir. Thank you.
Thank you.
Okay, sir.